Today we are going to discuss the sensitive soils. Unconfined compressive strength and sensitivity of clays. So that's the topic. The unconfined compressive strength Q sub U is defined as the ultimate load per unit cross-sectional area that a standard cylindrical specimen of soil can take under compression without any lateral pressure. So you are familiar with this term, unconfined compressive strength. Cohesive soils upon remoulding lose a part of shear strength. The loss of strength of clay soils from remoulding is caused primarily by the destruction of the clay particle structure that was developed during the original process of sedimentation and also disturbance to water molecules in adsorbed layer. So there are two things which are mentioned: destruction of the clay particle structure that was developed during the original process of sedimentation, and the second is the disturbance to water molecules in adsorbed layer. Sensitivity is the measure of loss of strength with remoulding. Sensitivity S sub T is defined as the ratio of unconfined compressive strength of clay in undisturbed state to unconfined compressive strength of a same clay in remoulded state at unaltered water content. So again, go through this definition. Sensitivity is defined as the ratio of unconfined compressive strength of clay in undisturbed state to unconfined compressive strength of a same clay in a remoulded state at unaltered water content. Clays are classified according to their sensitivity values as shown in table 1. So we are having following classifications: insensitive when the sensitivity is less than 1, slightly sensitive when the sensitivity is from 1 to 2, 2 to 4 means medium sensitive, 4 to 8 very sensitive, 8 to 16 slightly quick, 16 to 32 medium quick, 32 64 very quick, and greater than 64 it means extra quick. Highly over-consolidated clays are classified as insensitive. S sub T is mostly 1 or greater than 1, but for fissured clays means having the internal cracks, but for fissured clays S sub T is less than 1 because drawback in undisturbed soil is rectified in a remoulded state. So this is very, very important. I will again mention this thing, that for fissured clays S sub T is less than 1 because drawback in undisturbed soil is rectified in remoulded state. The sensitivity of most clays ranges from 1 to 8. However, highly flocculent marine clay deposits may have sensitivity ratios ranging from about 10 to 80. Some clay turn to viscous liquids upon remoulding, and these clays are referred to as quick clay. So this is the term quick clay. Description is here. Some clay turn to viscous liquid upon remoulding, and these clays are referred to as quick clays. Now there is an important term, Thixotropy, or you can say Thixotropy of clays. When clays with flocculent structure lose strength due to disturbance or remoulding. Loss of strength is partly due to permanent destruction of structure and reorientation of molecules in adsorbed layer. So again, look at the loss of strength. The loss of strength is partly due to permanent destruction of structure and reorientation of molecules in adsorbed layer. Strength loss with destruction of structures can't be recovered with time. However, the remoulded soil left undisturbed at same water content regain part of strength due to gradual reorientation of adsorbed molecules of water. This phenomenon of strength loss, strength gain with no change in volume or water content is called thixotropy. So basically this term thixotropy, it has been derived from the Greek. There is a word thix meaning touch and tropein meaning to change. Well, this may also be said to be a process of softening caused by remoulding, followed by a time-dependent return to the original harder state. Higher the sensitivity, larger thixotropic hardening. Extent of strength gain depends on the type of the clay mineral. Mineral that absorb large quantity of water in lattice structure, such as montmorillonite, has greater thixotropic gain compared to other stable clay minerals. Figure 1 shows the gain in strength of soil due to thixotropic effect. Thixotropy has important applications in connection with pile driving operations. The immediate frictional strength of thixotropic clay in driven piles is less compared to frictional strength after 1 month because strength gains with passage of time. So in this diagram, thixotropy of clays can be understood. Well, you can see here the shear strength, and this axis is meant for the time. So what is happening? We are having the undisturbed and fully hardened shear strength, this one for one particular soil. But at this particular time, the remoulding, because of the remoulding, you can see that the strength has been dropped to this. And then you can see that with the passage of time, that soil is hardening and regaining its strength. So this property is known as thixotropy. So without altering the moisture of that soil. Then again, remoulding, you can see drop in shear strength, and then with passage of time, the soil is gaining its strength. So this gain in strength, this property with passage of time without changing the moisture, this is thixotropy. Now on this particular slide you can see in this case this is A, this is the B diagram, and you can see that A diagram thixotropic material, completely thixotropic material, and B diagram is portraying the partially thixotropic material. So here you can see that complete thixotropic material loss in strength, but you have gained the initial strength with passage of time. Remoulding, you can see because of that you are having the drop in strength, but with passage of time you are getting the original strength. So complete regaining. But here the scenario is different. In this particular case, you can see that this was the initial undisturbed strength of that clay, but because of remoulding, the strength has been dropped to this. But then you can see that you are not in a position in this particular soil to get the original strength. So you can see that hardening is there, soil is gaining its strength but not getting its original, this one, initial strength. So this case I mean to say this diagram is portraying the case of partially thixotropic soils or material. Now here activity of the clay has been discussed. Activity of the clays, activity is denoted by capital A. Skempton in 1953 considered that significant volume change during swelling and shrinkage of clay is a function of plasticity index and colloidal clay present in the soil. Activity is defined as the ratio of plasticity index to the percentage of clay size fraction, where C is the percentage of clay size fraction, that is of particles of size less than 0.002 millimeter. Now in the case of activity, when we are considering the clay size fraction, it means the percentage of clay size fraction, that is the particles of size less than 0.002 millimeter. Activity is derived conveniently from slope of straight line graph between plasticity index and C. Pi is the plasticity index and C is the percentage of clay size fraction. A steeper slope represents greater activity. The figure 2 gives plot for clay soil containing different clay minerals: kaolinite, illite, monzonite. So for the clay, these are the three basic clay minerals: kaolinite, illite, and monzonite. Now here you can see the plot: plasticity index along vertical axis, the clay fraction along horizontal axis in percentage. So you can see that this is for kaolinite, this is for the illite, and this is for the monzonite, and you can see that the activity is maximum in this. So out of these three basic clay minerals, monzonite is treated as the most active clay mineral. So here in the table you can see the properties, the typical properties or typical values of liquid limit, plastic limit, and activity of some clay minerals: kaolinite, illite, and monzonite. So you can see that liquid limit ranges in these three different minerals, plastic limit, and the activity. So you can see the activity is maximum. So when your soil is containing monzonite as the basic clay mineral, so maximum change in the volume will be there with the change of moisture content. Well, in this last slide, you can see uh, a table is given, and clays can be classified on the basis of activity. We have already defined the activity on the previous slide. Soil classification based on activity value is given in this table. So if the activity is less than 0.75, it means inactive clay. We will be using this term inactive clay. When the activity is from 0.75 to 1.25, normal clay. That means there will be some change in the volume, but within some reasonable limit. But when it is more than 1.25, that means active. Clay minerals with kaolinite, a stable clay mineral, will have low activity, whereas those soils with monzonite, known to be a type subject to large volume changes depending on available water, will have high activity value. Activity has been used as an index property to determine the swelling potential of expensive clays. As far as the illite is concerned, the behavior of illite is somewhat intermediate between that of monzonite and kaolinite. So that's all about sensitive soils. Thank you.